Hello everyone, my name is Seth Hopwood. I'm a sales engineer with StorageCraft. I'm going to be going through a demo on our ShadowProtect SPX product, our cloud services, and our ImageManager products. If you guys have any questions along the way, I do have the questions field open. I will see them. Go ahead and feel free to jump in, ask any questions that you have that you can think of, and we can go ahead and get those answered. So where I'm going to start here is on an endpoint that has, I'm going to close this team viewer instance here. There we are. That has ShadowProtect SPX installed. So ShadowProtect SPX is our flagship product. It is generally designed to be used on servers, but it's got plenty of applications on workstations, desktops, laptops, things like that. It is an image-based solution, so it's going to be making backup images of volumes. We are backing up volumes at the sector level. So we are going to do incrementals, typically looking at volumes, the sector level. As those sectors change, we will be doing change tracking, and those incrementals will be just those changed sectors, right? We don't look at files and folders when it comes to backup. We are just looking at sectors. We, of course, can recreate the data, and it will result in files and folders. But you don't exclude files or folders. You simply select the volumes that you want to back up. So I'm going to show an existing backup job here. This is a backup job saying to back up my C volume. I've selected what I want to back up down here. I am backing up to my D volume. That is, those are 2 drives in a RAID 1 that I'm using for storage. That is also why I can't select it up as a backup, right? Being a destination, you can't back up the backup store. So I can only back up my C volume. I'm choosing to skip my system reserved. There are some consequences to that I'll talk about when it comes to restoring. I'll actually show that. And other than that, I've got compression. Typically, we see about 40% compression. That's at standard. There's very little overhead for that one. You can say best, which will see more overhead. By that, I mean if you do a restore of the data, it may take longer to do a restore, but you'll see about 50% compression. Most of our partners are doing just standard. So we do encryption as well. I'm doing AES 256-bit encryption here. When I create this backup job, I set the password, and that password will be what I use to do restores, interact with my backup images, etc. Do note that this password is not recoverable by StorageCraft. It's not recoverable by anyone. So if you set a password in here and you forget what that password is, you have lost your backups. So please make certain that whatever you set as a password in here, you note that, you keep good track of it. Otherwise, you may end up with a restore situation that has some complications. You set a backup schedule as well. This is going to tell our software when to do backups. We are able to do continuous incrementals. We're able to do a mixed schedule. We are also able to do a full schedule. I'll go ahead and show those over here. So what those types mean, full manual only ever runs a backup when you tell it to, and it's going to run a full backup, right? It's going to back up the entirety of the volume. So a few people have joined since we started. I'm going to recap super fast. This is ShadowProtect SPX, an imaging product. We image volumes at the sector level inside of a backup job. Oh, one thing I didn't mention, and I'll mention that, is that we are an agented backup, meaning you need to install ShadowProtect SPX on every endpoint that you want to back up, right? There are different solutions that are agentless backups for Hyper-V or for ESXi or for Zen. All of those are doing snapshots to drive their backups, which is some advantages and disadvantages. The biggest advantages of how we do them, which are agented, once again I say, is that we are living inside of Windows and we are taking backups of volumes. That means we are able to take backups from any Windows machine that you have and restore that Windows machine into any new environment that you want, right? So we can take machines that are physical, convert them to virtual machines. We can take VMs, restore them to physical bare metal hardware. We can do all types of restores because we are simply looking at volumes. We are also taking backups inside of Windows using VSS, which means that our backups are not very impactful on the machine. Typically, you can run a backup and it's not going to cause all kinds of headaches. Agentless backups, taking snapshots, a lot of times snapshots, your customers and users, everyone would notice that snapshot being taken. There's a performance hit there. So we are doing agented backups here. inside the schedule, well, there's also, there's what to back up, C volume, where to back up to is my D volume. That's why I can't select D volume here. We have encryption built in. The encryption password cannot be restored, cannot be recovered by us. I mean, if you lose this password, it's gone. So make sure that you don't lose this password. For schedule types, we have a full backup. It runs a full backup of the volumes when you tell it to, and that's it. It won't do anything else otherwise. It won't do any incrementals. It's just going to run fulls when you say do a full. The other type of just regular full does a full on a schedule, a new full backup set to a schedule you like. That can be useful for if your customers need an end of the month restore point or an end of the year restore point. And you can run that one-off full backup of their data and keep that. More commonly is mixed schedules. Mixed schedules work like old tape drive backups would work, where you're going to run a full on one day and then incrementals. I'm actually taking a backup right now. There it is running. It takes incrementals then throughout the business week, and then typically on a Friday, it starts a new full again, and then runs incrementals off of that full. It's making little short mini chains rebased every week, right? That's great for when there's no cloud component whatsoever, and you want to make sure that things are as restorable as they can possibly be. The downside to that is it uses much, much more storage space. It's also useful excuse me, if you want to do a drive rotation. You can schedule this so that the full backup happens between when you swap the drives out. So every time you swap the drives out, it does a new full as expected, then incrementals, then you swap it, new full incrementals again. I'm not a huge fan of drive rotation. There's a lot of problems with it, a lot of ways it can fail, but it's there. Most common is a continuous incremental. A continuous incremental will do one full backup ever, and then just incrementals moving forward. Every backup is at the sector level, just the changes from the last backup, right? So as this goes on throughout the months and potentially years, you're going to start to see thousands of incrementals, each of those needing all of the backups that came before it to be restorable. Without ImageManager, and notice it says that you need ImageManager right here. Without ImageManager, there's going to be problems here. That's why we require it for continuous. We'll talk about what that does, but from SPX's point of view, it's going to make that one full backup, and then it's going to just make incrementals moving forward, right? In our advanced tab, we have a few different options of note here. One is we can set a throttle. Generally, modern hardware, you don't have to worry about this. It's very lightweight, but you can set a throttle if needed on especially like older hardware. We do have scripting we can run. If you guys want to run a script before the backup or before the snapshot, we can do that. That's useful for if you want to, and I would only do this during after hours, run a backup of a database that is not VSS aware. So most databases are going to be Microsoft SQL database that is VSS aware. There is a Microsoft SQL writer they provide that when you take a backup, because we're using VSS, it's going to say to that writer, hey, you have to quiesce, we'll take a snapshot, resume, and we'll take that backup. They won't notice it's happening, but we'll take clean backups. Not crash consistent is the term there, where it is not like a system crash, it is more like a system shutdown from the point of view of the database. We also can do retention through SPX, only if you're doing a mixed schedule. And what SPX retention is going to do is you're going to say, how many image sets do I want to keep? And then once it gets past that number, it removes the oldest image set so that it stays true to that number. So the way that I have mine set up here, it's going to run a full backup, and then the next, and then the next. That fourth full backup, when it completes, it's going to remove that old image set, the first one. And then rolling forward, it'll just keep that many. Like I said before, mixed schedules do use up more storage space locally, and that is because to keep 3 image sets requires me to keep 3 full backups of my data. If I've got 2 terabytes of data, realistically, that's going to need about 4 to 5 terabytes of storage. Probably more like 5 or 6, actually. So there is that there. When you do a continuous, again, it's not going to do retention because there aren't image sets to keep. ImageManager does that. So that's ShadowProtect SPX. It's very straightforward, very easy to set up. You install it, you reboot it, you license it, you build a backup job. Can take maybe 10 or 15 minutes depending on how long Windows takes to reboot. ImageManager over here then is the companion piece. So where SPX is an agented solution that you install on each endpoint that you want to back up, ImageManager is more of a typically one per customer site setup, and you're going to have it manage multiple backups with this one install. ImageManager, just like ShadowProtect SPX, I should have mentioned this as well. SPX is what's called hardware agnostic. We don't care what you back up to. We can back up to a NAS, we can back up to an external, we can back up to internal drives like I am. We can back up to a dedicated backup server. That's what this machine actually is. It is called BDR Beta. It is a BDR, and I use this in terms of failover for immediate recovery of my data, etc. Right? We can back up to anything that is either a network share, so whack NAS, whack backups, whack domain controller, file server, whatever, or external internal drives. ImageManager then can manage those backup targets. So I can manage a NAS with this. I can manage, in this case, internal drives or an external drive with this. I just point it to where that share or where those images live. Typically one folder per machine being backed up, right? So in my directories here, I have the backup images. I then have the BDR beta for my BDR beta machine and my version 1 for my version 1 machine. ImageManager has three primary functions that I'm going to talk about first. The first one is verification. Very straightforward. Because StorageCraft considers every backup point sacred, it is a recovery point, we never write data into a backup file. Once a backup file has been written, we never change it. We never make changes to an existing file. So every file should, from the day it's created to the last day you want to keep it, always MD5 hash to the same value. So we just do MD5 hash checks of these image files, and if they fail the MD5 hash check, something has either changed that file, or if it's over a network location, you could have like a faulty switch or something and it's getting junk data back. That's a possibility. I've seen those. But it means either that file is no longer reliable because something has written data into it, be it a crypto virus, be it another program, be it whatever. Or again, if it's over a network location, it could be, a network issue. But it checks those every week. Every week it re-verifies every single piece of data to make sure that the data is good. That's how we're able to have a continuous incremental chain that lives for years, right? Because as long as the ones are ones and the zeros are zero, that machine's going to come back to life exactly as it is. We also have a couple other ways to make sure this data is good. I'll talk about those in a minute. Second piece is consolidation. Consolidation creates data, and that's what I want to stress the most here, is that it creates synthetic restore points that is using more storage so that rather than needing every single incremental file in a chain, it skips from day to day, week to week, or month to month. So you can see here the last file it created was a -cd file. The naming scheme is C volume, that's the volume being backed up. B002 means I've written 2 base images ever. If I look over at this one, it's B007. I've written 7 base images. Every time I say I want to leave this chain behind, start a new full backup, that number will increment to B008, right? Typically you don't see B00 numbers this high, but this is a test machine and I do all kinds of things and I break the backup, so I have to restart it from time to time. I065 means there's been 65 incrementals. Someone asked about ImageManager. Does it run at the MSP level or at the customer? ImageManager would run in the customer site. You would have one ImageManager at each physical location managing those backups. The reason you need it at the physical location is actually doing consolidation and verification over the WAN would be disastrous. It would be way too slow, right? So you do install ImageManager at the customer site. But again, one install can manage many servers, right? So if I have a customer with 4 servers being backed up to a NAS, install ImageManager there. My other customer has 32 servers, maybe 2 ImageManager there because the actual work of managing 32 backups, split that to 216 installs would probably be better. But yep, unless the numbers get very high. Typically, once you get around 20, I like to say keep those to 20 or less folders per install of ImageManager, unless that server's got some serious beef, right? If it's got 2 Xeon processors, a ton of RAM, and the storage target is pretty fast disks or SSDs, then you can usually get away with more of them. But so consolidation creates data, right? I065 is the 65th backup that my backup job has written for this base image. If I were to start a new base image, my first incremental would be I001. The base image actually wouldn't have an increment number, it would be a .spf for full versus I for incremental. This machine is on increment 1,284, right? It's taken 1,284 different incremental restore points. My chain is still healthy, my restores are still fast because of consolidation. So -cd means consolidated daily. There can also be -cw for weekly or -cm for monthly. Dailies connect to dailies or to a weekly once you go from a Sunday to a Saturday or Monday to Friday if you skip weekends, right? And then I can start skipping week by week or month by month. So you don't have to know how these build out, but I'm just going to show an example really quick here. I'm going to start by date modified. That's the last piece, by the way, is date modified is when my recovery point time is. So I can restore my machine to how it looked on December 31st at 6:05 p.m. or January 31st or February 2nd or 9th. And when I look at these files, I get a lot of information here. So SPF is my base image. My end of December is December 31st. My end of January is January 31st. These files all connect. If I want to restore this file, even though when this file was made, I had almost 500 backups made, I just need these 3 files to bring me back to this point in time. Moving forward, I can skip week by week into February, or I can skip just, don't want to do that. I'm trying to copy those. Thanks, Windows. I can skip month by month, right? Come on, Windows, work with me here. There we go. I can skip month by month and skip to end of February. I can look for end of April, which will be 3:30. And then, or March rather, than end of April will be 4:30 as well, because I don't run backups on the weekend, so it didn't work out. And then I'm back into May, and I can actually skip week by week. So I can look for a -cw file, there it is, and then 511. And I'm caught up to Monday, skipping all of those files. 1,250 incrementals with just 8 items, right? So restores can still be very fast. Trying to use 1,250 files is going to take forever. Trying to use 8 files, I'm going to be fine. But of note is it creates data, right? Notice my daily file here, my restore point of 510. I still have my hourly backups for this day. It doesn't take these files and smash them into a single file. It actually just creates a new synthetic restore point. I'm using more storage. I'm keeping both my intradailies 1.7 gigs, and then also a 800 meg end of the day restore point. Then with retention, that's able to say, how long do I want to keep all these different types of restore points? How long is it useful to keep an end of the day restore point, right? So in my case, I keep, and these are the StorageCraft defaults, by the way. If you turn on retention and you turn on monthly consolidation, these are the numbers you're going to have by default. For a week, I can restore to my end of the day backups, right? My intradaily backups are taken hourly, and for a week I can restore them. So I can go back to any hour that I want on the 9th. If I have to go back to the 8th, my hourly restore points will be gone. I will just have consolidated daily. Now, because I can skip day by day, week by week, and month by month, I can safely remove those files in terms of chain health. I just have to be aware of in terms of customer needs, how long I need to keep these numbers, right? As I turn these values up, I'm using more storage. As I turn these values down, as I tighten up my retention, I'm going to have less restore points, but be using less storage. With these default values, typically I tell partners, you want to have whatever their used space is, right? If they have one machine, go to that one machine. I'm backing up this volume. What is my used space? Well, this machine's tiny, 20 gigs. Let's say it's 200 gigs, double to triple it. I like to triple it when I can, but if it's a lot of data, you can get away with doubling it. Just you maybe need to have tighter retention. Tripling it gives you a ton of room for growth. So I would run, again, if this was 200 gigs, at least 600 gigs, I would just go with a terabyte. 500 gig drives aren't the worst, but it just seems a little silly, and a terabyte gives me plenty of space, right? So 7 days I can restore to the hour. From 8 days ago to 15 days ago, I can restore to my end of the day. Here's exactly how your server looked, either file restores or whole image, bring the server back to life on whatever hardware you want. Here's how it looked 15 days ago, 14, 13, 12. Once you get to 16 days, you've got end of the week. Here's exactly how your server looked at your last backup of the day, typically around 6 p.m. But it may be, they run hourly every half hour, so 11, 11:30, 12. Here's your server how it looked 12:30 or 11:30, 22 days ago, because that would be the end of the week, let's say. Here it is on the 4th at 6 p.m. You have all those restore points going back for end of the week for 3 months. Then you just have from 91 days to a full year ago how their server looked exactly as it looked at the very end of the month. So verification to make sure the data is still good after months and months and years. Consolidation to make sure we can restore data with expediency and allow retention so that you're not keeping tons of granularity of stuff from months and years ago, right? And everything just rolls forward. Once you get this set up, it becomes hands-off. Once it's going to keep 7 days. Once that 8th day comes in, removes it. 9th day comes in, removes it. 2nd day, 10th day, removes it. 3rd day, all the way forward, does it all automatically for you. The last piece I'm going to talk about here is replication. Actually, let's do a head start restore. I'm going to turn one of those on, and we'll talk about that in a minute. I'm going to do a VHD, head start restore. That all looks good. Head start restore again, I'm using my backup images. I have to enter my encryption password. There we go. I'll talk about that in a minute. So replication, taking the data, taking these backup images and sending them to the cloud or to any other location. So first type is to a local drive. I can take my backups wherever they're going as long as ImageManager can see them and copy all of them to a local drive. Now this is going to be local to ImageManager. So if I have 6 servers all backing up to a dedicated backup appliance, and that backup appliance has ImageManager, it's copying those backups to something local to that backup appliance, right? So what I could do is I could actually have my server back up to a NAS, keep an external plugged in, and keep a copy not just on the NAS, but on an external. Although if you were doing that, I would actually say have it back up to the external and copy to a network drive and copy it to the NAS. It's easier to back up local and copy it over the the LAN than it is to back up over the LAN and copy it local, but you could do either way. Network drive actually has some kind of cool implications that I've seen in the last few months, where if a customer of yours has 2 sites, or if you guys yourselves have 2 sites and you want to run backups, you can have SPX back up to a NAS at Site A, so all the servers in Site A back up to Site A, all the servers at Site B back up to a NAS at Site B. Then if you have a site-to-site tunnel that's always up, you can actually have them cross-ship to each other. So the NAS at Site A actually has the backups for A and B, and the NAS at Site B has the backups for B and A. So if Site A were to go down, Site B has all the backups. Kind of a cheaper, less, geographic distance between them probably, but still easy way to have an off-site replication of the backups. If you want to get a little more big than that, a little more distance in there, or go to a data center, things like that, we can do intelligent FTP replication. We can take these backup images and upload them using FTP or SFTP, either one, automatically, and have them go typically to a partner's data center or storage servers they have in their office, things like that. FTP, it's going to work, typically people run FileZilla FTP server, or maybe Cerberus if you want to kind of go more enterprise and get an SFTP server. And you just set it up the way you would any FTP server, and it's going to have a subdirectory for each machine being backed up, and it's going to upload and keep a copy of those images on that FTP target. ShadowStream is very similar. It is our proprietary replication software, so that's awesome because if you need support, we can't support FTP server setup. It's not our software. If the server itself has a configuration problem, we can't do anything about that. ShadowStream server is our product. So if you have configuration problems with it, things like that, we can help with those. It also is great for if there's compliancy concerns where you can say yes. everything is encrypted, everything is compressed. The data is encrypted, the data stream is encrypted, they're both compressed. Everything is as packed in as possible, as protected as possible for those compliancy concerns. You would run ShadowStream server, again, on a storage server typically owned by a partner of ours that would be hosting these backup images, right? Otherwise, it works very similar to FTP. You have users, typically one per customer. Each of their servers has its own folder as a subdirectory on their virtual root that it sends data to based on how you set up the subdirectory in here. We can go to Amazon S3 compatible storage. When you set this up, you'll need to have that S3 endpoint, a bucket, an access key, and a secret key. StorageCraft having no control over Amazon S3, you're at the mercy of that provider. What we can do is we can upload the base images, the monthlies, and the consolidated dailies. And that's what it's going to keep up there. Otherwise, it's going to keep the same retention scheme that you have here. So if you say keep 3 monthlies, we're going to keep 3 monthlies. If it says keep 1 daily, we're still going to have to keep at least a month worth of dailies because we have to build out that monthly file and have those available to be restored from in the middle of the month. So we're going to have a month's worth of dailies and 3 monthlies and the base image, and that's it. So whatever you keep locally, that's what we're going to keep. If you need to restore, if you need that data, however they offer it to get to you, however you can get it, you download it, you have them ship it to you, we can't help with that. So there is that concern there. Finally, there's the StorageCraft Cloud Services. This is StorageCraft's own cloud built by us to work with SPX and ImageManager. Our cloud is incredibly powerful. It's very, very cool. It is 100% self-service. I will cover the cloud portion of this at the end of the demo, but the setup of here is very easy. Each company being done backup for by a partner, or if you're buying, if there's cloud credits, we can do all kinds of different ways of doing this. Has its own unique login, right? So every company has its own login. That's how we credential. That's how we know where it belongs in our cloud. You need the image password. Replication mode. We are able to choose if you want to send the end of the day backups or intradaily backups. Intradaily backups do have a slight extra cost because our processing is much greater, but it means you can restore them to, the hour rather than here you are end of the day yesterday. Customer need kind of dictates which one you should choose here. And then we've got different service levels. So we can do backups that we just host backups. When you need them, we ship them out ASAP, or you can download them and it's just a store of backups, all the way up to we can do individual file folder restores from the cloud. And again, self-service full cloud failover. You're able to take these backups, turn these backups on, and run them as a virtual machine in the cloud during an emergency whenever you need. 24/7, you can just do it. We support full testing of that as well, so that when that time comes, you're not learning this process right then. You've got a document, you're just going through step 1, step 2, step 3, step 4, step 5, and then it's up and running, right? So in terms of SPX, in terms of ImageManager, that's a very basic setup I've got here. I'm running backups to my D drive being managed by ImageManager, sent to the StorageCraft Cloud and Cloud Premium. So then recovery operations, right? When disaster strikes, when you need things restored, what can you do? So by far the most common restore type is someone's got some data and they delete that forever on accident. They modify that, they screw it up some way or another. That data needs to be restored to how it looked, let's say, at my end of the day yesterday. So I can just look in my backups here. And this is BDR beta. And I can say sort by date modified, show me my most recent backups. I'm looking for 5/15. Every file with a shield icon is a restore point. And so here's my restore point at 6:05 p.m. yesterday. I can just double click on that file to say I want to open this up as a data volume. I don't have to know how to build out the image chain. It knows how, and it's going to build that out and present that to Windows as a data volume. So I've now got my volume here on my server twice. One is my live Windows install. If I make changes in here, I'm making changes in here. That's production. I'm making changes. But I've also got this virtual copy as a data volume. I can browse this, and it's the same stuff, but it's how it looked at 6:05 p.m. yesterday. And I can just browse it. And one thing I didn't consider is that this is going to run slower. Let me pause this job here. It's going to run slower because I'm actually reading from this. I'm reading from these images in 2 places at once and committing a virtual disk to it. So I'm going to pause that while I do this. I can go to desktop. There's my 3 pictures. I can just click and drag them, and they're back exactly how they used to be last night. And when I'm done, I can dismount it. That is by far the most common recovery operation. And that's usually about how long it takes. Is you have to find the image you want to mount. There's my restore point. I mount it. I find that data. I copy it back. I can copy that to an external. I can copy that to a flash drive. I can copy it over a Windows share. Whatever you want to do to get that data back, we can do that nice and easy. Second type of restore is a virtual boot. Well, the second type of restore would be a bare metal restore. I can take any of these images that I want, boot our recovery environment. I'm actually going to turn this on again really quick. I think we're getting pretty close. We're on 65, yeah. So we've only got a few left here. And I'll explain what's going on with this in a second. We have a bare metal restore. I can take my image files. I can write them to a disk. I can do it to a VM. I can, inside of a VM, make a virtual disk, restore that data into that and convert it to a VM. I can restore it to a bare metal restore. If I have, let's say drive failure, right? 6 drives fail on my server. I can go put new drives in, rebuild the RAID array, whatever. In the recovery environment, say, take this image, write this to the volume, and it's going to bring that machine back to life exactly how it used to be. Inside the recovery environment, it's as simple as, say, recover wizard or restore wizard, pick this image file, write it to this partition. Away it goes. If you don't remember how the partitions were laid out, we have a tool where you can say, look at the image, what was the partition layout before, recreate that, it'll partition it out, restore them to the partition they used to be in. Again, bring it back exactly how it used to be. And that's the most important thing, is every image needs to be restorable. Every image should be able to bring that server back to life how it looked exactly at the time of backup, right? So then I'm actually going to change this and say, can I? Is it going to let me? Say 1 day and see what it does. Yeah. Oh, password, right. Yeah. It should stop here. So then other types of restores besides bare metal restore, I'll show you kind of that in a minute here, are going to be a virtual boot. So what a virtual boot is, in the same way that I can take, oh boy, what is this thing doing? Let me pause that and enable it again. There we go, that's what I wanted to see. We'll see what it does. I may have just broken it. I shouldn't have fussed with it like I did. Virtual boot is we can take those images in the same way that I'm able to present it to Windows as a data volume, right? I can take any point in time that I want in here and say, hey, Windows, here's a virtual drive, here's a hard drive, show it to me, and it'll look like a virtual volume. I can take one of these, and it looks like it did get where I want it to do, where it stopped. I can take any one of these that I want and give it to a hypervisor. So I'm not doing a restore is the most important thing here. I'm not taking my data and writing this to a hard drive, to a virtual disk. I'm actually looking at my backup images, giving them to a hypervisor and booting it as a VM hot. So the advantage of that is I don't have to have that data committed anywhere other than in my backups. I don't have to have done any sort of preparation on this other than having a hypervisor. And I can just turn a copy on in a disaster, right? Hard drive failed, motherboard failed, whatever. If I've got a machine that can have the images and I can run the VM, I can boot this. Our supported hypervisors are Virtualbox, Hyper-V, and Vsphere. I'm using Virtualbox. Virtualbox and Hyper-V setup. The actual use of them are almost identical. It's not going to let me do that because I don't have Hyper-V installed. I'm using Virtualbox. Vsphere is a little bit different. It has a little bit of requirements. You have to check, make sure you meet all the requirements in our user guide. But for Virtualbox and Hyper-V, you just say that's what I'm using. Give it a name. Today is 5/16/2018 at 133. 2 cores, 2 gigs of RAM, that's fine. No networking. I do not want networking because my machine is actually booting itself as a VM. So I can go ahead and create it. Within about 5 minutes or so, I will have a copy of my machine up and running as a VM using just my backup images. This could be a production server, this could be a SQL server, a domain controller, whatever. I can bring this thing back to life in an emergency, just like it looked as of its last backup, in my case, half an hour ago. I can tell that by the 1:05 p.m. timestamp right here. And there we go. So what it's doing right now is a hardware independent restore. If I look in here, there's going to be a temp file. It's writing data to this file. It's a scratch file it's using to inject the drivers needed to live in the new environment. Now, because with a virtual boot, you select the hypervisor you're using, we know where you're going, right? We know where this thing will be living now as a virtual machine. So we know what drivers it needs to work, in my case, in VirtualBox. So even though my machine here is a physical machine with an Intel i5, 8 gigs of RAM, Intel motherboard, all that stuff, it's now going to be a VM inside a VirtualBox, and it's going to work. It's got the drivers needed. Now, the first time it boots, it's going to take about a minute and a half to massage itself with the drivers and such, but it's going to come up just fine. And I've done a physical to virtual conversion, just like that, right? I've also brought my, customer server back to life, just like that. Could be someone literally stole the server. They could unplug that thing and run off with it. They're going to sell it for parts. They're going to sell it to the competition. Well, we can't help with the competition part, but in terms of getting them up and running, here we go. Virtual boot, very, very powerful. With virtual boot then in a disaster, I of course would give this full networking. I would give it its old IP address, and everything would just talk to it the way that it used to. And I can run in a virtual boot state for, about a handful of weeks, maybe, 5-ish weeks around there is kind of like the limit where I start to get a little bit worried. Because we're not actually living in a true virtual environment on a true virtual disk, right? We are emulating a disk using the backup images. Very important with virtual boot is, in a disaster situation, you are able to continue doing backups. I can take this point that it's going to be booted in just a second here. I can give it full networking. I can point it to my old backup set and continue doing backups. And not just that, I can continue doing incremental backups. I do not have to do a new full backup in the virtual boot state, because if you actually think about it, to do a full backup, I would have to read through my entire backup set to write what would be mostly that exact same data as a full backup, probably to the same target, probably the same place my images live at. So it's going to run slow as heck to do that full backup, right? Because I'm reading it in here, I'm reading it as an emulated drive, and I'm writing to that disk to keep Windows alive, I'm writing to that disk to run my backup. All kinds of stuff's going to be really slow. So instead what we do is we're actually able to continue doing just incrementals. So from the point of right here to here, there was about 49 megs of difference. And then I can just keep doing sector tracking, change tracking, incrementals off of this file. So my backups are only going to take about a minute or two. Here's my machine exactly as it is, other than the resolution, as a VM, right? So also, because I'm still taking backups while I'm in production failover, thanks, TeamViewer. Oh, that's my VM saying TeamViewer is having a fit. That's funny. Let's just get rid of that. I can continue doing incrementals, which means when it comes time to do a fail back, it's been 3 weeks, I got the new hard drives, I'm ready to bring their production server back to life. Maybe it's a VM, maybe it's a physical server, doesn't matter, we can restore to whatever. What do I do? So one option, and it's the worst option, well, the worst option is it fails. It's the less effective option is what I'll say. It would still work, is I could turn this VM off, boot that hardware, boot the recovery environment, and say do a restore. And it takes maybe a day. Maybe I do that on Friday night, and by Monday, hopefully we're done and back up and running. But I can be better than that, right? What I can do is keep running my virtual boot and keep taking incremental backups. And I can say, hey, recovery environment, start this restore, but know that there's more coming. It's called a staged restore. Know that there's more coming, so write all the data you have now, but once you've written all that, hold off. Don't do anything. There's more coming. So I can queue that for Friday night, business continues in the virtual boot, right? Even if they're 24/7 shop, business continues in here. It continues taking incrementals. So that takes 8 hours. I come in, Saturday morning, they're still in business, they're still running, everything's still working in the virtual boot, and I can say, okay, now take that last backup you restored from Friday at 6 p.m., catch me up to Monday at 8 a.m. And let's say that takes 2 hours, so now catch me up to Monday 10 a.m. Takes 20 minutes. Catch me up to Monday at 10:20 a.m. Takes, 30 seconds. Turn the virtual boot off, turn the production server on, and they were at parity. They were the exact same data. Now I've gone from failover to production in the amount of time it takes like Windows to boot, right? Maybe 10, 20 minutes depending on the server, what it's booting. So total downtime, right? You guys get a notice, your pager goes off, your phone goes off, whatever goes off, customers calling you, 2 in the morning, server went down, something happened, right? Smoke's coming out of it, fire's coming out of it, which I've seen fire come out of servers before. We have to pull the plug, it's down. Okay, we virtual boot it, it's back up and running in 15, 20 minutes. Keep doing business, order in a new server. Server takes 2 weeks to get here, they're still in here, they're still running, they're still taking backups. Start that restore, takes 8 hours, 2 hours and 20 minutes. Now you finally turn that virtual boot off. Production finally stops for that short time while the new production server boots on. Total downtime about maybe 40 minutes, an hour, hour and a half, depends on some variables, but very, very quickly they're back up and running, failed back in production, everything, full disaster downtime about an hour. Really, really powerful, cool stuff. Other uses for virtual boot though. I'm able to do, one thing is, I know my backups work, right? This machine is taking backups. I know these backups are restorable because I did one. I've proven it. If I take this backup and I give this data to a hypervisor or a disk or whatever, Windows turns on, right? I could do this quarterly and say, here you go, your backup works. I'm comfortable with it. If something happened, you're good. You got you covered. Other things I can do. I can do sandboxing. If this were a SQL server, and the SQL software just came out with a new version and they need to update because they don't support the version they're on anymore, I can do that update in a Virtualbox, right? I can virtual boot this thing, run that update. Does that newest version still work with that database file? If it does, you're probably good. Good. You've tested it. You know it's going to be okay. If it doesn't, contact the vendor. Have them fix your Virtualbox. Don't have them bother with our virtual boot. Don't have them bother with the production one. Fix this. This doesn't work. Make this work. Note what the vendor does. Tear everything down, virtual boot it again, apply those fixes, and then update. Learn what it takes to make production go smooth in a sandbox environment, right? When I'm done with a virtual boot, I can just say, turn this thing off. And then Virtualbox is kind of cool and kind of scary in that when you delete a VM, and you say delete everything, this thing deletes everything. It's going to delete my incremental file in here. Virtualbox is super grabby, so just be careful with that. Hyper-V is a little less grabby, ESXi is less grabby. Virtualbox it just does it. It's ruthless. So, but for testing, I'm cleaned up. I'm done. I've done the virtual boot. I've shown that my machine boots. I'm done. Also really cool, you can have this thing virtual boot for you. You can have it automatically do an advanced verification that's going to say, automatically boot my backups every day or every week or every month and email me a screenshot of that Control-Alt-Delete login screen. And it can automatically do that verification of do my backups boot for you. You don't have to remote in and do it. You can just have it run every month. You can have that go to your end user if you want. You can provide that to them however you want. Really cool stuff. So that's a virtual boot. Another type, a similar end result solution, but different in how it works and different in its use cases, is a Head Start Restore. That's the job that I created here. And what a Head Start Restore does is it's going to take your backups and it's going to write them to a virtual disk file. So it's actually going to create a VHD, VMDK, or VHDX of your backups, and create and convert it into a virtual disk file, right? So what it does then is it writes the base image, it writes all those interdailies, writes all those incrementals, and it stops once it hits the lag time. What the lag time is for is that I can say a lag time of, let's say, 3 days or 4 days. It's kind of like cryptovirus protection or like catastrophic, data shift protection, things like that. You're able to say, take my backups, finalize to any point from my lag time to my most recent backup. When I finalize, you'll get to see that here. Right, I can restore from 8 a.m. all the way up to 1 p.m. today. Finalize this, and let me boot this as a VM. So I'm going to say, just do the most recent backup. I'm going to have to watch it write these 6 files. That's not a bad time. It won't take too long. And what it does is a full production quality failover with the speed of a virtual boot, right? But the difference is I am committed to a virtual disk file. My backups have been written to a virtual disk file. I am as rock solid as any virtual disk file would be, right? I'm as rock solid as their Windows install is how I would word that. If their Windows install is problematic, it doesn't matter if you move it, Windows itself is damaged. If their Windows install is good, but the disk has a problem or the motherboard fails or the power supply gives out, I can finalize this Head Start restore. And it's going to write those image files. You can see it doesn't take it very long. And once it's done, and I do have to finalize it, I have a VHD copy of their data as it appeared at the point I choose to finalize at, and I can boot that as a VM, right? So like VirtualBox, or like a virtual boot, I can say, go and turn this thing on as a VM in about 5 or 10 minutes. Now the consequences to Head Start Restore. One, I have to do it in advance. It's named a Head Start Restore because you got to do this thing early. You don't want to start doing this after a disaster strikes because a Head Start Restore by its nature takes a long time to restore. It goes in as granular steps as possible so it can meet any lag time requirements that you have, right? So when you do a Head Start Restore, you want to set this in advance. Set a lag time of maybe a handful of days. I like to do 4 or 5. Then I can finalize it and bring their server back to life very quickly. The other consequence is with a Head Start Restore schedulable and repeatedly schedulable. So what a Head Start Restore will do is one job will let you create 1 copy of their server. I could create 2 jobs and have one that I do testing with, let's say monthly, and the other one I just leave alone, right? And then that leave alone one is the failover, we need this ready, and then the first one is I'm doing a test of it, I want to make sure I can finalize it and the finalize works, etc. Head Start Restore by its nature continues rolling forward until you need it. So generally, unless you're very test intensive, you only need 1 per server that you want to be able to Head Start Restore. If you demand tests of it every once in a while, if you want to do tests every once in a while, you want to have 2 different jobs, and 1 is for testing, 1 is for permanent failover, right? A Head Start Restore is a production failover. This thing will be rock solid. Consequences, my backup images. When I do a virtual boot of this machine's backup is around 20-something, 15 gigs with compression. Give it a few months, it'll be like 25, 30 gigs. That's how much data I'm using. If I want to virtual boot this, all I need are the backup images. A Head Start Restore, I have a second copy of my data as a VHD, right? I'm using twice as much storage because I have a backup set that's about my data size times up to maybe times 2 after a mature chain get a full, 12 months compared to my VHD file, which will be about what their use space is because it's what's in the disk file, right? So this thing is done, it's finalized. My virtual disk file is ready. I can say in VirtualBox, create a VM, attach this virtual disk file, called it's called HSR test, HSR test. Today is 5/16/2018. This is a Windows 8.1 install, 64-bit. I want to use an existing virtual disk file right here. And I can go ahead and create that. Now, because this is a test, there's a couple things I want to do. Number one, I don't want networking. Number two, I do want to boot the recovery environment. The reason for that is twofold. Number one, with virtual boot, I don't have to do that step because virtual boot automatically does a hardware independent restore for me because a virtual boot knows what you're restoring to. It knows I'm going to a Virtualbox instance. Head Start Restore has no idea where you're going to. So the nice thing is it's general. I can Head Start Restore to a VHD. I can go to Virtualbox. I can go to Hyper-V. The downside is I do have to tell it, hey, here's the drivers that you need to live in your new environment. So the nice thing is, though, our recovery environment here already has the drivers needed to work in most virtual environments. So if I'm Head Start Restoring to Virtualbox or to Hyper-V or ESXi, it's going to have the drivers needed. I can just point it here, say click and start, and it's going to give it the drivers. It's going to take about maybe 45 seconds. It doesn't take too long. If I'm restoring to physical hardware, like a Dell that has a perk, the PowerEdge RAID card, perk RAID cards, I'm going to have to provide the recovery environment using this advanced button, that proprietary driver. Dell does not let us load that into our recovery environment. Dell is very tight with those. You have to get that from the vendor, the hardware vendor. Most hardware, we just ship with the drivers, right? Like Intel, regular motherboard, stuff like that. It's not a big deal. But you always can load custom drivers in here. It gives me a report of all the different drivers it loaded. So now I've got all the drivers needed to boot inside of Virtualbox. But the other thing I have to do is the boot configuration utility. If you remember my backup job, I'm not backing up my system reserved. Some of the jobs system reserved, among other things like BitLocker, is this is my active partition. I can actually look in disk management. And if I look at my partitions, here's my amazing dynamic RAID 1. I would never use this except for showing I've got a true RAID 1. This is active. Windows is not active. Also, the system reserved has the bootloader. My Windows install does not have a bootloader. The boot configuration utility, I can just click auto repair, and it's going to load in a bootloader. Now when I click auto repair, it'll identify there's a bootloader. This thing should be active. So I click it 2 times, and now I'm bootable. Now I'm active. The fact that I skipped system reserved, piece of cake to fix that. Over in Virtualbox, I can say no longer use my recovery environment, right? And boot. From time of finalize to booting this thing, total time is probably about 6 or 7 minutes, right? And just like virtual boot, I've got a copy of their server, of my backup, up and running, but the difference is this is a production quality VM, right? This thing is going to run faster. It's going to be more stable. I could leave it running like this for months if I wanted. I could actually have like a backup appliance that has all their VMs on it, and in a disaster, I could turn that thing into production, have it all fail over, and leave it there forever, and order a new server, and that'll now be the backup server, right? Don't even migrate back. Just, this is production now. Go, right? Near high availability. Not quite high availability, but close. Again, first time Windows boots, it's going to be a little bit cranky figuring out those drivers, but it won't be too bad because I know it's got them because I ran the HIR. So that's all of the recovery options that we can do locally, right? We've got a Head Start Restore, we've got a virtual boot, we've got file folder restores. In the bare metal restore, in the recovery environment, there was a restore wizard. Give it the image files, give it the volume, write it out. So then the last thing I want to show is our cloud. So in our cloud side of things, I alluded to Cloud Premium, and that's what I'm going to focus on most here. Over in Cloud Services, each company I provide backup for has its own cloud account. Inside of that cloud account, it has each of my servers that I'm doing backup for. This is actually version 1. I had to rename it. Compliancy for all machines need to have the naming scheme. And then my BDR beta machine. I can, whenever I want, 24/7, turn this thing on as a VM. I don't have to put a ticket in. I don't have to do any of those things. I can just boot this. In a real failover, checkbox real failover, it'll keep running as long as I need it. Otherwise, because this is a test, I don't need this alive for more than a day. If I forget to turn this thing off to kill this thing, just do it for me. And it's going to turn this thing on as a VM for me live. Now, note first thing it does is create networking. Every cloud account has its own pfSense firewall, and that pfSense firewall doesn't actually exist until a VM is running. But what you can do is set up all the networking, and you don't have to know how pfSense firewalls work to do this. Set up all this networking in advance, right? I can pre-stage all of this networking so that when I need it, it's already filled in, it's already there. I can do the same thing at their site with, if they have a firewall that can do IPsec, and that's how I want to get, the VMs in Utah here, or in Canada. If you're in Canada, we do have Canadian data centers for our Canadian partners and customers. They all go to Canada to keep it in their country. I can have that machine running in the StorageCraft cloud connected to the end user site. So I can set the remote network, gateway, shared key, get all this configured in advance so that during a disaster, I just say, launch my VMs, which notice I have a virtual machine policy. I can actually spec out in here. Oh, this machine's deleted, so let's go ahead and kill that. Yep, that's fine. Bring this over here. Again, anytime I want to use my backups ever, I need to have that encryption password. And I can say this machine is dependent on this machine. So this machine boots first. Once this machine boots, then sleep timer boot this machine. When I'm ready, launch VM policy, turns all my VMs on for me, right? Boots my domain controller, then my SQL server and file server. Doesn't boot them out of order because sometimes that's very important. If I have 30 VMs in here, I don't want to have to go and type in 30 different times. I set it up once and I can launch them all whenever I need it. Second thing, notice firewall status was build. That was the create networking stage. I click refresh here. It'll say firewall active. I am now welcome to establish that site-to-site tunnel with IPsec, or my customers can all run the open VPN client and VPN in, get access to those servers. I can set those servers to have a DHCP reservation of, let's say, 11, sure. And these machines will always come up with the same IP address, so I know what I'm going to need to have my customers use to hit those servers correctly. I can do public to private mapping to things like open up the, webmail.storagecraft.com or whatever. I can open up webmail addresses, things like that to the public. All that can be set up here in advance. If my customer's data is so large that uploading is going to be a problem, I can request a seed drive. It ships it out, you get it, you plug it into ImageManager, you tell ImageManager seed to this drive letter, it copies everything, says I'm done, eject it, ship it back. It's super easy. Here's my machine running in the cloud, and it's probably booting Windows. So that'll take a little bit. I can open this in a new browser. Once I have either the VPN set up or the site-to-site set up, I can RDP into it, I can do whatever I want. There it is, right? Virtual machines by default get 2 cores and 6 gigs of RAM. There is no cost to update that. You just request it and we can turn those values up. There used to be an option in here to turn that up. We had to take it away. Customers kept just setting it to the max every time for like file servers and stuff. So in terms of doing a fail back from our cloud, it works just like a virtual boot. We ship you an image, it has the backups, or a drive, it has the backups on it, you restore that, you say this is a cloud restore, it downloads rather than have locally, downloads all the changes from that point in time to what is right now. Once they're fully caught up and they're the same type, they're the same data, turn the cloud off, turn the local on, you failed back. So that is the demo here. Last things I want to mention, if there's any questions, go ahead and send them in. I'm happy to answer any questions. Otherwise, for support, we have a support team. You submit tickets. Tickets are handled based on both the priority and first in. So an emergency gets handled before anything else, production server down, stuff like that. We're going to handle those right away. Things that are best practice, we might get back to you within a day or two, depending on how busy we are, how swamped we are. You can imagine, when all the hurricanes hit southern U.S., support was a little bit behind because a lot of people had a lot of problems. You've got myself. I'm a sales engineer. You're going to have a sales engineer for your territory. You're going to have a CAM, an account manager for your territory as well. Both of them are here to help you. And any questions you have on best practices, configuration, sales, pricing, go to them. Specific problems of, hey, I ran the installer, it didn't work. I used to work, my backups just stopped working, typically go to support. But your sales team is always there for you. Whatever you need, they're there to help. So I don't see any questions. So that is it for this demo. Thank you everyone for attending. We appreciate your interest, and reach out to your sales team. We'll do whatever it takes to make you happy with the product, to try out the product. We've got free trials, all kinds of fun things like that. So thank you very much.